when we're graphing an exponential growth or decay graph that uses the number e, remember Euler's number of the natural base, we're going to follow the same rules that we did with any other exponential growth or decay graph. Remember, since e represents a number, all we have, I mean, think of e as being about 2.72, that's approximately what it's equal to. I have a base that's bigger than 1, and so in this case, having a base bigger than 1, remember the base value is all we look at, we know this is going to represent exponential growth. Now there's a couple ways we could make this decay instead, but I'm not going to worry about that right now. I have an exponential growth graph. Okay, so then rather than actually graph this by plotting points, because if I really needed to, I could use my calculator to graph this. There are going to be lots of irrational numbers with this, so I'm just going to make a really rough sketch. Really what I care about is just the domain, range, and asymptote. And as I just said, it's going to follow all the same rules we looked at in a previous video about graphing this. So I can see that based on this equation, I've got a -2 in the exponent. That's going to be my horizontal shift, which will move my graph in the opposite direction of what it says. So rather than going backwards 2 to the left, I'm going to go right 2 when I graph this. I'm just going to make a note of that. Like I said, I'm not going to actually graph any points for this one. The number that's much more important to me for this is the k value, the vertical shift, the number that's not in the exponent. That's going to move your graph up or down and do exactly what it says it's going to do. So my graph is going to be moved up 1 space. Okay? Well, my domain, as we've said all along, is always all reals. For any exponential growth or decay graph, our exponent can be anything we want it to be. The asymptote, though, has been changed, and specifically, it's that k value that's always going to change it. So our asymptote is normally the x-axis, y equals 0, but that horizontal line is going to move up or down if we move the graph up or down. So my new asymptote is going to be the equation y equals 1. So let me go ahead and graph that line, graph that line and draw that dashed asymptote in there. So that's the line that the graph's going to get really, really close to but can't touch. And then because I have a positive a value, I mean, I'm just going to make a really rough sketch. I know they're all going to basically look something like this. If you want to plot points, then go ahead and graph it on your calculator and find some points. But I know that's the basic shape it's going to take. For my range, then, we're going to say my range is going to be all the numbers that are bigger than 1. Remember, the range will change like the asymptote changes. And I can't be equal to 1 since the curve never really gets there. So those are going to be my range and my asymptote, just the same way we did with any other exponential growth or decay graph. Don't let that e mess you up at all.